Welcome back. In this video, you'll learn to control the brightness of an LED based on the position of a potentiometer. This is an opportunity to use one of the Arduino's analog input pins. Aside from the potentiometer, you can use the analog input pins of your Arduino with devices like the light, temperature and flex sensors, accelerometers, gyroscopes, Hall effect sensors, or any device that can output voltage within the acceptable 0 to 5 volts that the Arduino Uno can work with. For this project, you'll need a potentiometer, the LED setup from our digital output example on pin 11, and a few jumper wires. Place your potentiometer on the breadboard. Connect one outer pin to 5 volts and the opposite outer pin to GND or ground. The middle pin, or the wiper, as it's called, will connect to analog pin A0 or analog pin 0, giving us a variable voltage reading as you turn the knob. The rest of the circuit that includes the LED remains as in the previous videos. Open your Arduino IDE and start with the code. This Arduino sketch reads the value from a potentiometer and uses it to control the brightness of an LED. It also prints the potentiometer's value to the serial monitor. Here's the breakdown of how this code works. This line declares an integer variable pot pin and initializes it with A0, indicating the potentiometer is connected to the Arduino analog pin A0 or analog 0. Here, the integer variable LED pin is declared and set to 11, specifying that the LED is connected to digital pin 11. Port value here is declared as an integer and is initialized to 0. This variable will be used to store the analog value read from the potentiometer. The setup function is called once, as you know, when the sketch starts. In this case, it sets the LED pin as an output using pin mode. And then serial begin initializes serial communication at 9600 baud rate, allowing data to be sent to the computer's serial monitor. Inside the loop function, which runs continuously after setup, analogRead pot pin reads the analog value from the potentiometer and stores it in the port value variable. The map function is one you haven't seen before. It remaps port value from its original range, which is from 0 to 1023, to a new range, which is from 0 to 255, which is suitable for controlling LED brightness. This value is then stored in LED brightness. analogRead, that you have seen before, is used to set the brightness of the LED connected to LED pin. The brightness level is determined by LED brightness, which was derived from the potentiometer's position. The current potentiometer value, which is stored in the variable port value, is sent to the serial monitor using serial.println, allowing you to see the value in real time as you adjust the potentiometer. Finally, the delay function pauses the loop for 10 milliseconds. This short delay can help with debouncing the potentiometer and makes the serial output more manageable by slightly slowing down the rate at which data is sent to serial monitor. This sketch demonstrates how to read an analog input, map its value to a different range, use that value to control an output device, in this case an LED's brightness, and output the read value to the serial monitor for debugging or monitoring purposes. Upload your sketch to the Arduino, then turn the potentiometer's knob. Watch how the LED's brightness changes in sync with your adjustments. The serial monitor will show the potentiometer's analog value, giving you insight into how analog input is read by Arduino. You've just unlocked a new level in controlling the physical world with Arduino. Using a potentiometer for analog input opens up many possibilities for your projects, especially for reading values from various analog sensors such as gas, moisture, sound, light, and flex. If you found this tutorial helpful, please give it a thumbs up and subscribe to our channel for more Arduino tutorials. Your support motivates us to keep crafting content that fuels your maker journey. Until next time, keep experimenting and exploring.